So, in this lesson, I'm gonna offer some basic concepts in geometry that you want to be familiar with. So, the first thing we're gonna talk about is line. What is line? Well, now many of you may think of a line as just something that looks like that. But, in geometry, a line has two arrows and so it extends in opposite direction forever. Now, let's put some point on this line. So, we can call this line AB. We could also call it line BC. And we could also call it line AC. So, there's many in which we can name this particular line now.
Now, how about array? How would you describe array? Array has a point and it extends forever in the other direction, so it has a point and a row. So let's put some other point and on this array. Let's call this a BC. So we can name this array a C. Or we can name it array not BC but a C. I mean a B. The reason why we can name it array BC because the first point has to start at the initial point or the end point of the array, so we need to use point as our starting point.
Next one you need to be familiar with is something called a segment. A segment has a beginning and it is an. So let's say this is point A and point B, so we can describe it as a segment AB with no arrows on it, or we call side. This is segment BA, so that's a segment.
There is 4 different angles that you need to be familiar with. So the first one is an acute angle. Acute angle have an angle measure of anywhere between 0 and 90, but it less than 90. That's what you want to take from this, and so we can call his angle ABC. And if you notice, an angle is formed by the union of two rays. So here we have ray BA and ray BC, and so they form a vertex creating an angle. The next angle is the right angle, and the right angle has an angle measure of 90 degrees. The next one needed to be paired with something called an obtuse angle. So the obtuse angles has an angle greater than 90 but less than 180. And finally, you need to be familiar with the straight angle. The straight angle has a measure of 180 degrees. So that is straight angles. It looks basically like a line. Now, let's move on to the midpoint.
Let's move on the main point. What is main point? Well, if you look at the word, it sounds like the point in the middle, and you would not be incorrect by saying that. So, let's say if we have a segment, we will call it segment AC, and let's say it's the main point. So, what does the mean? That means that B is right in the middle of segment AC. It also means that segment AB and BC are congruent. So if you put this mark, it shows that this segment is equal to that segment. And the way you would write that is as follows. So you will say segment AB is congruent to segment BC. And so if that's true, that means the B is the main point of segment AC, thus B bisects segment AC into two equal parts.
So let's say if we have a segment, we can call it segment IC, and let's say it's the midpoint. So what does that mean? That B is right in the middle of segment IC. It also means that segments B and BC are congruent. So if you put this mark It shows that this segment is equal to that the segment, and why you would write that is as follows. You would say segment AB is congruent to segment BC, and so if that true means that B is the midpoint of segment IC. This B bisects segment IC into two equal parts. Now another term you need to be familiar with is something called. What just happened here? Something called a segment bisector. So let's say if we have a ray the base through the midpoint, let's say that this is our ray RB is considered a segment bisector because it bisects the segment into two congruent parts. So we can see that IB and BC are congruent to each other.
Now another term you need to be familiar with is something called what just happened here, something called segment bisector. So let's say if we have a ray that pass
Now, let's move on to parallel lines. So, what do you know about parallel lines? What are some properties of parallel lines? Parallel lines never intersect. So, let's call this line A and line B. Parallel lines also have the same slope. So, let's say the slope of line A is a half the slope of line B. Will also be a half, and the way you can describe that these two lines are parallel are the geometry symbol for it. Looks like this, so you say it's a parallel to B. You would use two lines to indicate that A is parallel to B. What are perpendicular lines and how are they different from parallel lines? As we said before, parallel lines do not intersect each other, but perpendicular lines, they do intersect each other. In fact, they do so at right angle. So let's call this line A and line B. So they are gonna meet at 90-degree angle. Now let's say the slope of line B is positive 2 over 5. What is slope of a line given that is perpendicular to line B? To find the slope of a perpendicular line, first you need to flip the fraction and change a sign from positive to negative. So the slopes are negative reciprocals of each other, and a symbol for it goes as follows. So we could say a line is perpendicular to B.
Next up in our list of things to discuss is the angles bisector. So what is an angle bisector? An angle bisector is a ray that bisects an angle into two equal parts. So let's say we have let's call this angle ABC, and we have a ray that emanates from point B, and let's call this ray BD. So ray BD is an angle bisector if it bisects angle ABC into two equal parts. So let's say that angle ABC is 60 degrees. By the way, when you name an angle, the vertex of the angle has to be in the middle, so you can call it angles ABC, or you can call it angle CBA. So B has to be in the middle. So if ray BD is an angle bisector, that means that angles ABD has to be 30 and angles DBC has to be 30.
Next, we have supplementary angles. Like we said on the last topic, you can probably guess what this is about. Supplementary angles are angles that add up to 180. Now, if you remember, a straight angle has an angle measure of 180. So we need to be dealing with a line, so let's put some points. Let's say this point A, B, C, and D. Let's say angles ABD has a measure. What would you say it? So we now remember a straight angle is 180. So 110 plus what number is 180? This has to be 70. So because the measure of angles ABD and the measure of angle, let's call this CBD, or you could say BDC, because they add up to 180, we could say that those two angles are supplementary angles.
The next geometric term that you need to be familiar with is something called the transitive property. So, what is the transitive property? The definition is as follows: if two angles are congruent to the same angle, then they are congruent to each other. Okay, so what does that mean? Let's say if angle 1 is congruent to angle 2, and if angle 3 is congruent to angle 2, then we can come in with this conclusion. We could say that angle 1 is congruent to angle 3. And now it seems obvious, but you need to know that this property isn't match this situation, because if you are doing, let's say, a problem with two column proof, you need to know that the transitive property corresponds to this particular situation. Now, another way in which you could describe the transitive property is used in variable. So you can say that if A is equal to B and if C is equal to B, then that means that has to C. So we can write then A is equal to C. And that's the basic idea behind the transitive property. So that's something else that you want to add to your notes.
You need to be familiar with vertical lines. If you're working on two-column proof and problems similar of that, so what are vertical angles? Well, we can form vertical angle by drawing two lines that intersect each other. Let's call these angles 1, 2, 3, and 4. So the opposite of angles are congruent. Angle 1 is congruent to angle 3. So the truths, you can describe them as vertical angle 2 and angle 1. They are so vertical angle. They are congruent each other. So let me give you an example problem. Let's say if this angle is 50, what are the other three angles? This angle has to be 50 because their angles vertical now. These two angles, let's call this angle X and 50. So they from a linear pair, so therefore they have to add up to 180. 180 minus 5 is 130. So the angle opposite to 130 is a vertical angle too. So this must also be 130, and so that's how you can use vertical angle to find missing angle.
Okay, sekali lagi. Now let's talk about median. What is median? To understand this concept, let's begin by drawing a triangle ABC, and we are gonna draw a line segment from B to some point which we'll call D. Now in the example segment, BD is a median. A median is a line segment drawn from the vertex of triangle to midpoint on the other side of triangle. So that means that B is the midpoint. So if B is the midpoint of segment IC, that means AD and DC are congruent to each other. And so that's what a median does. The median is just a line segment. It touches the midpoint of the other side and it splits one side on triangle into two equal parts.
Now, let's talk about altitudes. What is an altitude and how does it relate to a median? So, let's use another triangle as our example. Now, we are going to call a triangle ABC. Again, with point D. So, this time BD is going to present an altitude. So, like a median, altitude is a line segment, but the difference is D is not a midpoint. The altitude forms a right triangle with, in this case, segment AC. So, angle ADB, which is congruent to angle CDB, both angles are equal to 90 degrees. So, the altitude from right angle inside the triangle, and that's what you need to know. Now, we can also say that segment BD is perpendicular to segment AC, because perpendicular line and perpendicular segment, they insert at right angles. So, if you have an altitude, you can also make the statement. Okay.
Now the next thing we're going to talk about is the perpendicular bisector. So, looking at the words perpendicular and bisector, what do you think this represents? So, let's say if we have a line segment which we'll call segment AB, now we are going to draw a line that's perpendicular to it. And let's call this line out, so line L. Line L is perpendicular to segment AB, which means that is going to form a right angle with a segment AB. Now, it's also a bisector, so if we draw another point, we will call it point M. M is the midpoint of segment AB. So, a perpendicular bisector forms right angles with this segment that is intersects, and at the same time it also bisects the segment into two parts. So when dealing with perpendicular bisector, you can say things like segment AM is congruent to segment BM. You can also say that M is midpoint, and you could also say that angle at some point here. So let's call this point P and point Q. So we could say that angle AMP and angle BMP, these are right angles. So perpendicular bisector, they are lines that bisect a segment. They are into two equal parts and they form right angles. With that segment, personally, I like to think of a perpendicular bisector as a hybrid of median and altitude. So, like a median, it touches the segment at the midpoint and it bisects into two equal parts, and like altitude, it forms right angles. So, it features of both. Now, there's something else that you need to know about perpendicular bisector. Let's focus on point P. So notice that AM and BM, they are congruent each other, and these triangles, they share a common side PM. Therefore, because the two sides are the same, and this side is a common side which is associated with the reflexive property, it turns out that AP is congruent to BP, and so that's another feature of perpendicular bisector. is that any point on the perpendicular bisector is equidistant to the endpoints of the segment that is bisect. So P is equidistant to point A and B. So we can say that AP is congruent to BP. Now we get to see, we could also say the same of PQ. So AK, BQ, they're congruent to each other. So these are something that you want to keep in mind when dealing with this perpendicular bisector. A common problem.
Terakhir, you're going to encounter in geometry is proven that two triangles are congruent, and so let's say if there are two triangles we are dealing with, we have triangle IBC and triangle DIF. Now therefore postulate that you need to be familiar with. There's some other one too, but we're gonna cover for them. So let's say that a B and D are congruent to each other, and BC is congruent to IF, and IC is congruent to DF. Then we could say the triangle IBC is congruent to triangle DIF according to the SS postulate, because all their sides are congruent each other, and so that the first postulate you need to be familiar with. Now when you write this expression, you need to write it in such a way that the letters of each triangle correspond to each other. So angles correspond to angle D because they are opposite to congruent side. Likewise, angle B correspond to angle E. They are opposite to congruent side, and so we need to make sure that they match when right in this statement. And angle C correspond to angle F. Now let's look at another example, but let's use different letters. So let's call these triangles XYZ, and let's call this triangle RST. And let's say that segment XYZ, segment XY is congruent to RS, in segment XZ is congruent to RT, and angle X is congruent to angle R. What particularly can we use to prove that these two triangles are congruent? So we have a side and angle and a side, so we could use the SIS postulate to make the statement. The triangle XYZ is congruent to triangle RST, and so that's the second postulate that you need to be familiar with in order to prove the two triangles are congruent. Now, once you prove the two triangles are congruent, you can also make another statement. For instance, now that we know that these triangles are congruent, I can say that angle Y is congruent to angle A. And the reason why I can say that is something called corresponding parts of congruent triangle are congruent. So once you prove the two triangles are congruent, then you can make a statement that other portions of the triangle are congruent as well using this reason. Now let's try another example. So let's call this a triangle M and O, and this one we are gonna call it GHI. Now let's say that angle N is congruent to angle H, segment MN is congruent to segment GH, and angle M is congruent to angle G. So what postulate can we use to prove these two triangles are congruent? Susah. Now let's try another example. So let's call this triangle M and O, and this one we are gonna call it GHE. Now let's say that angle N is congruent to angle H. Segment MN is congruent to segment GH, and angle M is congruent to angle G. So what postulate can we use to prove that these two triangles are congruent? So we have angle aside and angle, so we could use the IIC, postulate angle side angle, to say that triangle MNO is congruent to triangle GHE. So now that we have proven that the two triangles are congruent, I can make a statement and say that another proteins of the triangle are congruent. I could say that MO is congruent to segment GI, and a reason is CFCTC. Corresponding parts of congruent triangle are congruent. Now there one more postulate that I want to go over. So let's say that is triangle ABC and this is a triangle RST. Let's say that angles I is congruent to angle IRT, angle C is congruent to angle T, and let's say that BC is congruent to ST. So what postulate can we use to prove that these two triangles are congruent? So here we have angle and a side, so we could use the IIC postulate to make the statement the triangle IBC is congruent to triangle RST. And so that the fourth postulate, you want to there another one called the hypotenuse, like postulate.
To go out, maybe grab some food and we could talk about what's your favorite color, what made you be who you are, who you are. 'Cause time seems like it'd be right with someone like you by my side. And my heart's been hurt one too many damn times, but with you I'm down to give it a try. Down to try. Baby, what's poppin'? How you is? Hope I'm not.
Myself, but now